Hi everyone. I would like to do about 3 more acid-base neutralization reactions. This is considered a little bit of extra help. So let's write sulfuric acid, which is H2SO4, and that's going to be on the table, AQ, plus potassium hydroxide, -1, +1. I should be putting the charges in. This is -2. This is +1. So reflecting on the charges is the hardest part of this. Acid plus the base is the salt plus water. Double replacement. So we are going to recombine these ions. So the potassium goes first. It's going to collide or recombine with the SO4, which is a -2, plus H plus OH minus. If we lost 1 electron, potassium's an alkali metal, it can only be +1. This gained 2. So we have to equal this out. We need a subscript of 2 down there. In these reactions, the quintessential Regents trap is that you can't not correctly write the formula for the salt. So now, clearly, we have to look at the balance. I can see right off the bat, there's a subscript of 2 here. So it kind of seems logical. I'm going to have to put a coefficient of 2. So what's the consequence of that? 2K plus, and now we have 2 here. All right, that looks good, but the coefficient of 2 impacted the hydroxide. So let me just take care of that. Put a coefficient of 2 here. 2 hydrogens, 2 hydroxides. But you know, that really helps because 2 hydrogen ions are here and 2 hydroxides are here. So it looks like this is done. 1 mole of sulfuric acid colliding with 2 moles of potassium hydroxide yields 1 mole of potassium sulfate plus 2 moles of HOH. Now here's a little secret assignment just to make sure you're listening. On the Google Classroom, what is the gram formula mass of potassium sulfate? Type it in, and I'm going to put secret question, and we'll see who knows what that means. So the secret question is, what's the GFM of this? K2SO4. It's a metal plus a polyatomic. It's a salt. It's ionic. It's ionic between, but covalent inside. Okay, let's do 1 more. We have H3PO4 colliding with CaOH taken twice, calcium hydroxide. This is phosphoric acid. It's on the table. And this is calcium hydroxide. It's an Arrhenius base because it gives up the OH. Put in the charges. So phosphate has to be a -3, reverse crisscross. Hydrogen has to be a +1. Calcium +2, -1 hydroxide. Has to be +2. Alkaline earth metal. Group 2, 2 words, +2, lost 2 electrons. Now, recombine. Acid plus the base is a salt plus water. So we put the metal first. We always put the positive species first. Calcium +2. Going with the PO4. which is a -3. All right. We have to be mindful that these charges don't balance. So this lost 2 electrons. This species gained 3. So isn't it true? We have to put a 3 here and a 2 there. Has to be. 3 times 2 is a +6. 2 times 3 is a -6. Plus, what's our last product, people? If it's neutralization, HOH. So one of the products is water. I apologize, this didn't make it all the way across. But if we take a look at this, we have to realize, oh, we're definitely out of balance. So let me see if I change colors, if it helps. 3 H's over here, 3 H's over there, no. But let's see what's going on. Now, of course, I can balance it by inspection, and in the interest of time on our video, I'm going to rush it a little bit. This is trial and error, but I'm going to bring my calciums up. So if I bring up calcium with a 3, isn't it true that calcium ion is 3 and now this one is 3? So that's cool. But look at the consequence of this coefficient. 3 times 2 is now 6 hydroxides. Let's go for it. If I put a coefficient of 6 in front of there, that takes care of that. But now my hydrogen ions are out. So if I'm putting a 6 here, I have 3 here. 2 times 3 would be 6. What is the consequence of this coefficient? 2 distributes to the phosphate. So this is 2. That's good. That's good. Because we have 2 times 3 is 6 H's, 2 phosphates, 3 calciums, we have it there, and 3 times 2 is 6 OH. Done. We've complied with the law of conservation of matter and energy. And we're reviewing balancing, which we haven't touched on in a while. One more for the road. HNO3, which is nitric acid, plus barium hydroxide. Complete the reaction. Acid plus a base is a salt plus water. So charges, -1, +1, has to be. No subscripts. Barium +2, hydroxide -1. Barium is an alkaline earth metal. Hydroxide is on table E. Hydroxide is always -1. Metal plus the polyatomic. What type of bonding? Both. And this is acid, this is base. So we know it's going to double replace. So writing the product down here, the barium +2 is going to collide with the nitrate. -1. And then HOH. So that could be the first layer of the question. What salt do you make? So it would be barium nitrate, but we've got to be careful. What do we have to be careful of? Barium nitrate. This is a +2, this is a -1. You must write the salt correctly. If you can't balance it, chances are you blew it. You blew it on the salt. So here we go. 2 nitrates here. I'm going to use a coefficient of 2. So we get 2 H pluses. Where should we go? Let's go here. brings us 2 hydrogen ions. So 2 hydroxides. Nice, 2 hydroxides already built into that formula. So I think we're good. I think we are good. 2 nitrates, barium, hydroxides. We got it. Okay, so acid plus a base is a salt plus water. Thank you for listening. You can get the secret question, the embedded question, which is what is the gram formula mass of potassium sulfate? And I really hope you're doing well, and I'm trying to make these videos as clear as possible, so I need your feedback. And we'll catch each other really soon for acid-base titration. Okay, bye.